Hello everyone. In this video, I'm going to explain about how to write the CNC program for milling operation for creating a pocket here. So diameter of the cutting tool is 20 mm. Here radius is represented as 10 mm. Okay. So the problem is something like this. The component to be machined is shown in figure. It is assumed that pocket is through. That is, the pocket is completely for this 10 mm depth. That's why this is represented as a through pocket, and hence only outside is to be machined. So that's why if you done the machining, this outside part, automatically the entire portion we can remove. Okay. The tool to be used is 20 mm diameter slot drill, or if slot drill we are not using, means suppose if you are using any end mill cutting tool, then first you have to create the hole using drilling, then you can use end mill cutter for creating this pocket. The setting is done with point A as reference, that means this is our datum point, and the reference axes are along x and y. Okay, this is the information given. Now we'll see how to write the program. So first step is, here I am writing the first block. So here sequence number or block number I am taking as N001. This N is indicating the block number or sequence number. Okay, so here I am taking the first block number as 1, and G92 is used to preset the datum position. So datum position I am setting at A. This is my 000. So that's why, so G92 preparatory function I am using to set the datum. Okay, this part only you have to write. This part is only for our understanding purpose I am displaying here. Next, I am using in the second block. This is the block number. This block number, any number you can give. I am starting with 1. You can start with 10 or 20, whatever your choice you can take. Okay, N002 is the second block. Then G90 is representing the absolute coordinates. So that means suppose I want to travel from point A to this point B. So absolute coordinates are 25 and 25. 25 and 25 only you have to take. Okay. Next, now the third block. In the third block, I am representing G00 preparatory function. G00 is representing rapid transfers. That means without doing any cutting operation, you can move the tool quickly to the required point. So from this datum point to this particular point, I am moving the tool. Okay, this particular point coordinates are x25 and y25. X25, y25. Z I am taking as 2. So this is, so origin point for Z, this is Z0. Z2 means somewhere here. So above the workpiece, we will get the tool position initially. Then T01 is representing the tool number in the tool magazine or turret. So first tool I am using. So S is the speed function. So here I am taking speed as 3000 rpm. So M03 is to start the spindle. Okay. So now somewhere here initially tool will be there. So from here to here I am moving the tool using this particular G00 preparatory function, something like this. Now the tool will move from here to here. You just observe, now tool is moved from here to here. And if you observe in the front view, so initially tool will be somewhere here. Now it is coming to 2 distance. So above Z the distance is 2 now. Okay. Next, in the fourth block, now I am using the preparatory function G01. G01 is for linear interpolation. That means along the straight line you are doing the cutting operation. So here Z, XY values I am not changing. XY values I am not changing. That's why here I am not writing XY, means the previous values it will take automatically. For G01 also, for linear interpolation also, during the cutting operation also, X and Y coordinates it is not changing. So previous x and y coordinates only it will consider. it will consider the tool, previous tool, it will consider the speed also. Okay, then what is the change we are getting here is feed is changing to 120 per second. Then this z coordinate is changed to -12. So this is 0, z0. -12 means this is 0, up to here it is 10. -12 means beyond 10 it is moving, because it's a through slot, through pocket. So to getting the through pocket, it is going beyond 10. That's why we are taking 12. Z is -12. Okay, observe here what is happening. Now tool is going up to -12 distance. Okay, that is about fourth block. Next operation is in the fifth block. I am taking y as 75. That means z value I am not changing, x value I am not changing, and feed also I am not changing, speed also I am not changing. All the values I will take from the previous blocks. In this block, the only changing parameter is coordinate y. So coordinate y 75 means this is 0, 0, 75 means up to here. Now the tool will travel from this position to this position. Okay, something like this. So in fifth block we are getting this operation. Next, in the next block, in the sixth block, I am taking x coordinate as 65. That means this is 0, 0, x coordinate 65 means up to here it is moving. That means I am removing the material here to here. Here to here I am removing the material now. Okay. So here to here, now tool is moving. The tool movement you can see in the top view as well as in the front view. In both the views here you can see the tool movement. Okay. So now in the sixth block we are changing the position of x from 25 to 65. Next, from this position onwards, from this point D onwards up to point E, it's a curve. That means circular interpolation we have to use, and this circular interpolation is along clockwise direction. So that's why here I am using G02 function. G02 is circular interpolation in the clockwise direction. Y coordinate in this operation is ending point of y coordinate. That means up to E is 25. Y coordinate is 25. So that 25 we are writing here. Apart from the giving y coordinate information, we have to give the information of center of the circle also. To define the center of the circle, I am taking the help of second reference coordinate system, that is IJK coordinate system I am using. So IJK means I will be parallel to x, j will be parallel to y. Okay. So here what we have to do is, for this particular arc, center is somewhere here. This particular center point you have to consider as the origin for IJK coordinate system. Okay. Here this is the center for this particular arc. This particular center point you have to consider as origin for IJK coordinate system. If this is the origin, then I will be something like this, positive I. Positive j will be something like this, negative j will be something like this. Then what will be the coordinate of point E with respect to IJK coordinate system means I coordinate system, I coordinate value remains 0, I is 0, j coordinate value will become -25, because this total distance here to here is 50, here to here is 25, then automatically this distance will be 25. So this is in the negative direction with respect to j. That's why j equal to -25, -25.0. Something in this way you have to define the center of the circle with respect to IJK coordinate system. Here I am taking I and j because parallel to x and y we will have I and j coordinates. That is the second reference coordinate system. Okay, so that information I have clearly written here. The point is, so the center for this arc somewhere here, that you can define with 0, 0, then automatically point E coordinates will become 0 and -25 with respect to ij. Okay, that is very important point here. Now you can see the circular interpolation. The tool is traveled from here to here. In the next block now I am representing G01. G01 is again the linear interpolation. So that means along the line you can do the machining. So here E to this particular point B is along a straight line only, and the destination coordinates are, so y coordinate I am not changing, only x coordinate I am changing as 25. Okay, y coordinate I am taking the previous value. That's why no need to bother about y coordinate. X coordinate is now 25. Okay, enter 25 as x coordinate, x equal to 25. Then the tool will move to this position. Okay, here double x is there. This is typing mistake. You consider this as x 25.0 only. In the next block, in the ninth block, now I am taking Z2. So total machining is over. We have started here. We have done the total machining. That means pocket is created. Now we have to take the tool out of the workpiece. For that I am taking Z value as 2. Then observe the front view. What will happen? The tool will move above the workpiece. So 2 mm above the workpiece. Okay. So up to 2 mm above the workpiece, I am taking G01 only. That means here the machining is done. So tool is rotating, and feed also, whatever feed we have taken earlier, that feed is given until the tool moves 2 mm away from the workpiece. Later in the ninth block, in the 10th block, what I am doing is I am going for rapid transfers. G00 means rapid transfer, Z equal to 50, and M05, that means you can go to 50 distance above the workpiece, and you can stop the spindle simultaneously. Like this, spindle is stopped and the tool is moving 50 distance away from the workpiece rapidly, quickly. Okay, so that's why this preparator function is changed from G01 to G00. So here preparation function is not given, means previous one it will take, that is G01. Okay, now the tool is somewhere here. The next block is representing the next, in the next block will represent how to take the tool to the origin position, like this. In the 11th block, now I am taking G01 only. So here preparator function is not given, as previous one only it will take, and xy z coordinate remains same. Xy coordinates only I am changing from 25, 25 to 0, 0. That means tool is traveling here to here, like this. Okay, so now tool is reached to its original origin point or datum position. Then the last block is representing the end of the program. M30 is representing end of the program. If it's a NC mission, you can rewind the tape. If it's a CNC mission, computer numerical control mission, then rewinding the tape is not required. You can again go back to the program. This is the simple program to explain the, this is the fundamental and simple program to explain the CNC milling operation. Here we have not taken any cutting tool compensations. In the next program I'll explain about cutting tool compensations. Thanks for watching my video. If you like this video, please subscribe to my channel.